So for my Piaget theory experiment, I chose activity 7, which is about the conservation of water and the quantity of water when you're using it. So students were given 4 containers. They were presented with containers A, B, C, and D. And they were asked to compare the quantity, the amount of liquid in each container. So containers A and B are supposed to be the same container and have about the same amount of liquid. We then take container B and pour it into container C. The hardest part is not pouring that liquid, or spilling that liquid, I should say. And then again, we're asked to compare. And lastly, we take the container C and we pour it into container D. And children again are asked to compare. You'll see like container D, we barely have any liquid in there at all. So that's the experiment portion. In this experiment, we're dealing with the quantity of liquid not changing no matter the container shape or size. We're dealing with that liquid forms to whatever container it's in, and we're also dealing with perception tricking us sometimes. So what I did was I interviewed 3 students ranging from 4 to 5. And while I interviewed them, I asked them about, like what their containers were holding, what they thought was in their container. And I want to pull up the exact words that they said. Okay, so I had Ronan, he is 4, and I'll go through kind of what each of them said in the stages. I had Jazzy, age 5, and Demia, age 4 as well. What I saw in my sensory motor stage was, I believe, only Ronan responding. And I had asked him, does the height or width of a container affect how much liquid it can hold? And he didn't respond. Part of that, I think, was because he was scared to get an answer wrong or didn't have an answer. And that can show his underlying lack of cognitive understanding, which again, at 4 years old, I wouldn't expect him to have all of those skills refined. He was more interested in physically interacting with the containers, which can show up that lack of abstract reasoning because we have those gross motor skill functions that we are inclined to do. All of my other students demonstrated pre-operational stage cognition. They were more interpreting visual cues to rely on their perceptions rather than understanding the idea of conservation. And they were able to focus on one piece of information or stimuli at a time, and they could understand the reversibility of pouring, but still are having a really hard time with that conservation piece. For example, when I asked Ronan, do you think the size of the container will change the amount of liquid inside? Why or why not? He said, well, big boxes hold big stuff. And it demonstrates his lack of understanding of conservation by assuming that because the container is bigger, the quantity of liquid is more. Again, he's relying on his perception, and he's assuming that the larger container automatically means a larger quantity of liquid. I asked him, now that we have poured the liquid from container B, our cup, into container C, our large and narrow, is there less water or more water in container C? And he said, yes, there is more water in container C. In fact, it's going to spill and make a mess. Again, he was focused on what he could visually interpret, and that appeared again when I transferred the continents of container C into container D, our very flat and wide container. When I asked him if there was less water in container D, he said, I think so, which again was demonstrating his ability to really focus on the appearance of that object. When I asked him how can we make sure the amount of liquid has stayed the same, he firmly said it didn't. He held that firm conclusion because reflecting on what he saw in the reverse pouring, again, he saw this container looks like it holds more. And he wasn't able to apply that logical sense of reasoning that we would see in our more concrete or formal operational stages. When I asked Jazzy, our 5-year-old, which container do you think holds the most liquid or the highest quantity of liquid, she said, container A. And I think she was relying on visual cues. That was after she had looked at container A and B with the liquid very closely for a pretty long time. And again, I tried to get those containers as accurate as possible, but she interpreted container A as having just a little bit more. When I asked her if two containers have the same quantity of liquid or amount of liquid, why might they look different? She said, magic, like Frosty's hat. She's been watching a lot of Frosty the Snowman. And so again, she was able to use magic as a way to explain why the liquids might look different. And it shows her use of imagination in place of logic. I asked, now that we have poured the liquid from container A or B into container C, is there more water in container C? She said, that's a trick. I know it's a trick. She was very firm on that. And again, she was able to see that there was some sort of connection happening there, but she wasn't able to articulate what it was. So it shows emerging awareness, but she was not able to yet connect the pieces for that. I asked her, now that we have poured the liquid into container D, is there less water in container D? And she simply said, trick. Similar to the previous response, she couldn't get that logical piece. Moving on to Demia, another 4-year-old, when I initially had asked her, which container do you think looks like it has the most quantity of liquid and which has the least? She said, container D, as a response to which has the least, and she was relying on the visual cues to determine which container held the most or the least. I asked, why do you think the amount of liquid might differ from different containers? And she said, it looks different. The student again focuses on the visual cues rather than the quantity. I asked, if two containers have the same quantity of liquid, why might they look different? And she said, well, this one is fat, again focused on container D, and focused on those visual cues. The conclusion to this research that I had was, while students demonstrate some understanding of the content that we're trying to express here, like the conservation of liquid, their ability to apply logical reasoning fell short, which I would expect for children their age. One of the things that I had noticed was many of my students aligned with the stage that Piaget's theories said that they would be in. However, I don't think that that age is a firm number, because I did have Ronan, who was 4, still fall back into some of the sensory motor areas, but also Ronan is a student who's a little bit behind developmentally than his other peers. So that, I think, makes a little bit of sense, but I agree with his theory. I just don't know if those ages are super firm all the time. I also suggest that students are more successful when an experience was tied to hands-on learning experiences, and that this reinforces the need for more instructional strategies that involve both concrete and abstract reasoning skills linked together. And I believe that our instructional and curriculum goals should be designed with students' cognitive development in mind.